So the expert systems was an attempt for people to create a computer program that behaves like an expert. And that's why they're called the expert system. And what does an expert do? Take some well-known experience and knowledge and then combines it together with the current situation at hand and produces some results from it. And the expert systems were quite popular in their traditional form around the 80s, 90s. And there were quite a lot of different forms of those, from decision trees where if then else rules were combined and you end up in some result. There were others that were making business process modeling as part of the expert systems. Some of those were using predicate logic, which means things like generalization. If a cat is an animal and Jim is a cat, then Jim is an animal, and so on. So there are a lot of different attempts, and they're all based on, we know a lot of facts, and then we need to have some computer system or some formal way of capturing them so we can combine them with the data we have and get some decisions. In our team, in John Fox-led team, we try to apply that in medicine, and medicine, like a lot of other areas, is characterized of uncertainty. It's a quite chaotic and vast domain of knowledge, and we don't know all the details. So talking about strict if then else doesn't always work well because the body is very complex. But we have well-known facts coming from randomized controlled trials, like other papers and experience. And we have other situations where we don't know all the facts. Sometimes we have contradictory facts, but we still need to make a decision in the end, and that's what an expert does. So we took we added a few features into the system that made that possible. The first one is that we made the possibility for the rules, instead of being this Boolean if, then, or true and true equals true, we made the flexible summarization system. So we get a lot of different rules. You can add them weights, you can define how these weights are combined, you can make them exponential, so some are almost exclusive and some are, or we can make them more mild, etc. And that led us to be able to get different rules from different knowledge and summarize them into some suggested action. The second part we added is, because exactly this is not, we don't know what's the truth all the time, we added a nice tracking system where its rule, its claim or argument, what we call it, where you can trace it back on the source where it started. And that means that you can know the quality it has, or you can add context when it's required. And sometimes that context is missing from the data. That could be a small detail about the population that this study, that the rule comes from, has some characteristic, and then you realize that in your real life, that's not the exact population. So adding that transparency, we also added the ability both for the system to reason a little bit about the quality of the rules, but we also create a nice trace visual to the user, which is the actual expert, where they can evaluate, agree with some rules and disagree. So in some ways, we made a unique expert, which is the combination of the human expert with a computer expert system. So that gave us the opportunity to write with confidence software that recommends decisions fully transparently to experts, and the experts can trust it or not trust it and review them. Based on how well established is a knowledge of some domain, we can trust the computer to make decisions 100% by itself when we know a lot about it. Like, for example, we know in some cancers, which we've done a lot of research. In other areas, you need more human contribution. But the human itself, because it's limited about the knowledge, can trace, read, and understand the problem, and then contribute to resolve where the uncertainty or the conflict